got slightly obsessed with trying to make logic gates out of simple components. This follows on from a Year 9 lesson where we were looking at logic gates, and we built simple and OR gates just out of using some very simple modular electronics called economatics. Unfortunately, it doesn't seem to be made anymore because I'd like to buy a whole set of these for use in class. I priced up making a set of logic gates using Little Bits, the modular magnetic electronics, and I worked out to make a single binary half adder was going to cost me about £60. I thought, well, there's got to be a cheaper way of doing this. So I've been experimenting with using a relay, because you can make lots of logic gates using relays, simple ones anyway, AND gates and OR gates we just made using light bulbs and switches. To do a NOT gate, however, which is the third logic gate I normally teach, is a little bit more complicated. So I've decided I needed a relay to make a NOT gate, and I managed to find this little relay here, this cute little relay, which I paid about £5 for in Maplins. I think if you bought one online, you could probably buy one for about 70p, probably. So I paid way over the odds, but it was worth getting because it does actually fit on a breadboard, which is seems to be quite elusive. If you Google this topic, it's very hard to find relays that fit on a breadboard. This will be powered by a 5-volt supply. It'll only switch up to 120 volts, but that's fine because I'm only switching an LED on and off, which is being powered by a 5-volt power supply, which is coming in at the back of the breadboard here. What we've got here in the relay are two completely separate circuits. So the LED is wired up through one circuit. This is through the normally closed circuit. Relays often have normally open and normally closed circuits, so this is why you can use it as a NOT gate. And I've wired the LED up to the normally closed circuit, which means electricity is flowing through the relay even when it doesn't have power to that separate part of the relay part that does the switching, the bit with the magnetic coil. And separate to the circuit going through the LED, I've also got 5 volts going through this switch. Now this switch is in the off position at the moment, and yet the light, if you can see, the LED is on. Now if I press the button, therefore you would think turning the circuit on, the LED goes out. And I take it off, there we go. So it's kind of doing the reverse, it's kind of making a NOT gate. At the moment the switch is off and yet the light is lit. If I push the button, and you get a satisfying click in the relay, push the button down, the switch is now on, and the light goes off. So I have reversed the digit. I've turned a 0 into a 1 into a 0, a true into a false into a true.